Hello, everyone. I'm George. I'm the CTO of Opinum. And today we're going to talk about the Data API and specifically about the new features. The agenda for today, first we're going to have a quick overview about the API and the security, just to make sure everybody is on the same page. Then we will talk about data loss detection on variables. Then about the statistics on variables, the second level data query, and finally we'll have a Q&A session. If you have any questions during the event, don't hesitate to send the questions. I'll try to check during the presentation. Okay, the goal of this section is to make sure that everybody following the session knows the basic of using the Data Hub API. Data Hub has a REST API that you can access through the Swagger application at api.opinum.com. And you will be able to find more information on the documentation website on docs.opinum.com. For the security, we use OAuth2 and OpenID Connect. And to authenticate, you will have to send an HTTP post request at the following URL, so identity.opinum.com/connect/token. The parameters will have to be sent using a form URL encoded. Those parameters are the grant type. In this case, I will use password. Then you will have to provide a client ID and a client secret. To get those information, you will have to contact the Opinum support. The Opinum support is available at support.opinum.com. You will have to specify which scope, so that drives what you want to access. In this case, we only have the OPSense API. You can also have other scopes if you want to send data points. And then you will have to use your credentials. Obviously, this is not my password. Once you send this request, you will get a JWT bearer token as a result. It will look something like this. It expires, in this case, in 3,600 seconds. But this is configurable based on your use case, so we can tweak this information. And this token will have to be used as an authentication header for all the subsequent HTTP requests to the API. Okay, now that we are aligned on the basics, let's dive into the new features. The first of which is data loss detection on variables. To illustrate the feature, we will use the case of a device, a meter, a sensor, or whatever it could be, that sends data at a regular interval to Data Hub. Please note that the fact that the device sends data points one by one continuously, rather than all its data points once a day in one shot, is very important, but we'll talk about that later. So we have this device that sends its data, but at any point in time, we can have a problem. Whether it is a power outage or a network outage, or just the device that is broken, at some point the data flow might be interrupted. All the new data point will then either be not sent or lost. This event is important to you, our clients, and we created the data loss feature in order to detect it as fast as possible. The principle is as follows. We will monitor an input variable and report its state on an output variable. The output will be binary, so it's ones and zeros. But first, we have data point flowing to Data Hub. Based on those data points and the moment we have received them, we will calculate an average period. Every time we receive new data points, we will update this average, keeping the last 100 data points. Important note, we will use the date at which we have received the data point and never look at the actual data date. At this point in time, the state is okay. And we will write 0 on the output variable. At some point, the time since the last data point received will exceed the missing signal factor. We will talk about that term later. Times the average period. The state will then be set to missing, and the output variable will receive a 1. Then new data point will arrive. Those new data points will be used to update the average period again, excluding the time between the last data point before the gap and the new ones. This will then reset the state to OK, and the output variable will be set to 0 again. We also have a mechanism to detect a permanent data loss. In this case, starts the same way as the previous one, but with a small twist. Again, data points are flowing. We calculate the average period. The state is OK. At some point, like on the previous example, the time between the last data point will exceed the period of the missing signal factor multiplied by the average period. And then we go to the missing state. But then if we continue to be in this state, at some point, we will exceed the other factor. So it's the abnormal period factor. And what happens then is that we will flush the data we have for the average period. So we flush the data from the last 100 data points because we consider the communication to be permanently lost. And therefore, we have to recalculate the average period because it might have actually changed. When new data will come in, we will start the process all over, calculating a fresh average period. The state will then be set back to OK, and the output variable will go back to 0. So we've now seen the possibility to configure those two parameters for the input. Those two parameters are the missing signal factor. It's actually how many times there can be between the last data point and the new data point. The second one is how many average periods should we wait before we consider that the data loss is permanent and we should not trust the average period anymore, which, as we've seen, will force the process to recalculate the average period again when the data flow is restored. In terms of configuration, we can also have some configuration for the output variable. In this case, you will be able to choose the variable name and the mapping config. The output variable is managed by the data loss system. It will be created automatically when you configure data loss on a variable, and delete it if you either remove the data loss detection from the input variable or delete the input variable. Be aware that if you delete the output variable, this will also remove the data loss detection from the input variable. Now, in the API, you will be able to find this new API on this index, so on data loss detection. And the documentation is available in docs.opinum.com/articles/signal loss detection/introduction. This principle will be applied on different kinds of signal. So in the future, we might also implement something that detects that a new data file has arrived or not, or if a report has been generated, and so on. Now we're going to move on to the statistics on variables. With the existing API, and specifically the Get Data API, you can already easily retrieve all of your data points and plot them on charts for analysis with a relatively high level of grouping and some transformation. But if you need to compare your data against a threshold over a certain period of time, up until now, you have to do it yourself. With the new statistic API on variables, we give you the ability to get better insight on your data in a very easy way. So what kind of data can you retrieve? Let's take a simple example with this small set of data with an arbitrary threshold. Running the statistic API against this will give you the following. First, the sample count. It actually is the number of data points that were used on the period that you have defined. And we have the above threshold sample count, which is the count of all the data points that are above the threshold. Same principle for the below threshold sample count, so the data points below the threshold. The rising edge count, it's every data point, so it's the count of every time the data points were crossing the threshold. So in this case, we can see there's only 2. We also have the falling edge count, which in this case is also 2. Then we have the above threshold total duration. So it's the duration, the sum of the duration of all of the data points that are above the threshold. Same principle for the below threshold total duration. We also have the min and the max duration for those two. So in this case, for the above, the minimum duration will be this one, and the max duration will be this one. Then we have the above threshold duration ratio. That's actually the percentage of time that we spent above or below the threshold. We have a maximum value, this one, minimum value. And then we have the average value and the average above and the average below values. So let's take a few use cases. Now, we're going to take the temperature data of Belgium for this year. If you live in Belgium, you probably remember that this summer was not exactly great. So if we use a threshold of 25 degrees, we can see the following results. There was, for this year up until today, 6,429 data points, with only 90 data points above the threshold, so above 25 degrees, the rest being below, and 90 hours this year of temperature above 25. We can also see the minimum and maximum value, respectively 29.3 and minus 8.5. From this, we can then take a look at the result from 2020, which was way better. Now, we can already see that we had more time with 25 degrees or more, but we can also compare that we have significant differences with the min and the max temperature. For the next use case, I will use a data loss output variable. As this is a binary variable, the threshold must be set to 1. And for this case, we will look at the result over a period of 6 months. Those results are telling us that the input variable had a relatively high amount of data loss. So we counted 954 data points at 1, which means that the data was lost, or at least considered lost, and 238 hours during which we didn't have data. And we can see that there was a very high period of 65 hours during which we didn't have data. Also, we can see that we have 223 rising edge count, which means that potentially the device that is used behind might not be trusted too much. Right, we'll now have a look at the parameters that are necessary to call the endpoint. First, obviously, you need the variable ID. You need from and to date to determine the boundaries of the research. In this case, you have the choice between providing the dates in the ISO 8601 format, which is a standard human-readable date format, which looks like this. Or you can use the epoch, which is the number of seconds since the January 1st, 1970, and it looks like this. You can choose to include or not the boundary. The idea is that if you want to compare a full year, you can take as a from date the 1st January of the year, and then if you set to not include the to boundary, that means that you can set the to date to the 1st January of the next year, and this is going to be then excluded. So you will have the last second of the year that you want to run the algorithm against. Then obviously you have to provide the threshold value. Also, you can set which time zone you want to use. If you say that you want to use the reporting time zone, that means that it will use the time zone of the site of the device. Or you can also provide a time zone ID. Here again, you have the choice on the format. You can either use the BCL format, which is a Microsoft format. For the time zone in Belgium, it's going to be called Roman Standard Time. You can also use the IANA TZDB format, which is definitely not the number of seconds since the 1st January 1970. So that's a mistake. But the time zone is going to look like this, so Europe/Brussels. We also have the result aggregation, but this is a bit more complex, so I'm going to explain this a bit more. So for the result aggregation, we're going to use a variable that has one data point every hour, and look at the statistics for a full year. If you set the result aggregation to none, that means that we're going to check every single data point. So you will have the raw data, so about 8,760 results. Then if you use the result aggregation in day, we're going to group in day, so you have 365 results. Month, you have 12 results, and year, you only have 1. Our ambition is to take this feature even further by integrating it into dashboards. If this presentation gave you ideas on how you could leverage it, I'd like to invite you to join us in our roundtable later on today. There will be 2 sessions, one at 2:30 p.m. in English and one at 3:40 in French. Also, I'd like to tell you that this API, even though it returns the count of data points, is not the one you should be using if that's what you need. We have a dedicated API for this that has been tweaked for the best performances that is available at this endpoint. So it's basically api.opinum.com/variables/ the variable ID that you want to look at, and then count data points. And as parameters, you can give the from and to dates, similarly as we have just seen for this API. We're now going to look at the second level data query API. So the second level data query feature allows Data Hub to retrieve a result set and apply another query on it. to expand the possibilities to tap into the data. This process works in 2 steps. First, you need to provide parameters like a usual getData request. While the filter is not identical, it is extremely similar and you should not be lost. Then you must provide the second level query using a SQLite syntax. The process works as follows. When you call the API, the first level filter and the second level query are transferred to our data service. The data service uses the first level data filter to fetch the data from our data hub storage. This result set is then transferred along with the second level data query to our SQLite engine, which will load the data into an in-memory data table and applies the second level filter. Finally, the result of the query are sent all the way back as a response from the API call. Here is an example of a getData request, more specifically a response. The second level data query engine will transform this result into a data table that will look like this. In all cases, this will be the format of the data table against which you will be able to query. The result will include some metadata. So first, the input rows count. Basically, it's the amount of data point that was returned by the first level filter. The output rows count. So after applying the second level query, it's going to tell you how many rows are in the result set. The input rows fetch duration. So basically, how long did it take to apply the first level filter? The query duration. So how long did it take to apply the second level query? And then you will have the data, which is basically a list of rows with the fields that might look something like this. So for each row that you will receive in the data set, you have a list of fields with the name of the field and the value of the field. We are going to look at a few use cases to demo the capabilities of the feature. In the first case, we will run a simple query to retrieve the different variable IDs that are present in the result set. Please note that this is definitely not the best approach. The get variable endpoint has an easier interface and will obviously be way more performant. Looking at the result, we can see that for each row, we have a single field called var, as defined in the second level query, with the according value. For the second example, we will sum the values and group by variable IDs. Again, this is not the best, the simple option. A simple get data should be here as well, easier to use and more performant. So the SQL query would look something like this. And the result set, we can see the rows containing the single field sum value with the value that was calculated. In the third example, we will get the min and max values grouped by month and day of week number. As you can see, this is already more complex. For the results, one more time, we see that the result contained the list of rows and the requested fields. For convenience, I have mapped the result set back into a table so we can have a better look. Final example, we will get the min and max values by readable day of week. So in other words, Monday, Tuesday, etc. query is quite more complex. I believe that now you understand the concept of the JSON results. So this time I directly mapped the result into a table. This API comes with a few limitations on the data filter. So there is no display level like you have in the get data. The output is driven by the second level query result set. There is no source ID, variable ID, or variable type ID, like in the get data again. If you want to provide a single one ID, you will have to provide a list with a single element. There is no paging. For this, you can use the native SQLite limit to control the number of rows and the start offset in the result set. There is no user restriction definition. So this API is not compatible with the date ranges that we use for the get data. And you can't specify more than one aggregation. There's also some limitation on the SQLite query. Only a single query is supported. No multiple comma separated queries, so you cannot chain different queries. There is no SQL statement other than select from data that is allowed. The query may only use the data table, so the table is always named data and has the format that I already presented you. And the format, to be more precise, is as follows. So you have a field called variable ID that is an int, a source ID that is also an int, the value is a double, and a timestamp. Common table expression are not supported. So the common table expression, it's when you start with a with keyword. So this is not permitted. And join clauses are not supported. Now we are going to go into the Q&A part of the session. So if you have any question, you can still see me. If you have any question, don't hesitate to send them in the chat. Right, so if there is no question, all is left for me is to thank you for joining me. There is a question. Shoot. About the amount of data we can store. I believe you can store terabytes of data, but then you will have to check with the pricing because you will have to buy multiple packs of variables. So I don't see this being a problem. Yes, you can store terabytes of data. Obviously, if you do a calculation on terabytes of data, it's going to take more time. It's kind of difficult to predict how much time it will take, but we should be able to run some benchmarks. But the additional data loss variable, are they counted in the billing? Because we would like... That's a very good question. So the previous way we would calculate the pricing was in the data point, and that's why you only have a data point when the state changed to very much limit the impact on the pricing. We recently changed the pricing to be variable based. So that's I'm going to validate that with my colleagues. I'm not completely sure. How fast is what? So the second level query. So if we are talking, yes, compared to basic REST. Okay, so the principle is not to be faster. The principle is that we can very easily map the data into a data table and execute a SQLite query on it, and that will return you results that you would not be able to do other way, or you would have to do yourself. But that would mean that you have to implement like either the SQLite engine or to write the code to analyze the data yourself. So the point is really not about performance, it's really new functionalities. I would say that it depends. It depends on the complexity of the query and the size of the result set. If you take a variable that gives you a data point every 5 seconds for an entire year and apply a very complex SQLite query, it can take a while. Although we believe that the most important thing is that you can make data transformation, grouping, ordering in a very specific way that wasn't possible before. So yes, it can get slow if you have a very big data set and a complex query. But in most cases, I don't think it's going to have a very big impact. Well, if there is no more question, thank you very much for joining me. And I invite you for the next session with my colleague Stefan, who is going to present you the alarms and the new features we have on this side. Have a nice day.